In this video, we are going to be talking about proportional relationships, how to identify them in graphs, in tables, and how to create equations with them to answer problems. Here's our lesson outline. So the first thing we are going to talk about is what is a proportional relationship? Then we'll identify them with graphs, then in tables. We'll write equations and then use those equations to help us solve some problems. All right, so what is a proportional relationship? Well, if you think about rates and unit rates, what we already have covered, let's remember a couple of things. A rate compares two different units. For instance, if I have, say, 120 miles. So if a car can travel 120 miles in 2 hours, that is my rate. But if I want to convert that to a unit rate, I can divide by that denominator and I get 60 miles per 1 hour. This is my unit rate. Okay, this is stuff that we've already covered. Our rate, what's given to us, and our unit rate. But if a unit rate repeats itself, it will turn into a set of points and it will create a line once you graph it. For example, if I look at this graph, it says family road trip. And if I look at my rate is right here, 120 over 2. That's what this point represents. Okay, the number of miles over the number of hours. So the number of miles is 120 over the number of hours, which is 2. Okay, that gets me 60. That's 60. Look at this point. 180 divided by 3 is 60. 240 divided by 4 is 60. And if I keep going, I'm going to get the same unit rate over and over again. That is called a proportional relationship. Okay, where the unit rate is called, it's also called the constant of proportionality because the unit rate is constantly the same. It's happening over and over again. It's the same number over and over again. No matter which point you choose to look at, you'll get the same number. Okay, so when we're talking about unit rate, it's also considered the constant of proportionality, which is a proportional relationship. Okay. So let's look back at our lesson outline. What is a proportional relationship? We just saw an example of it where the unit rate is constantly the same. Okay, now we're going to go into looking at identifying proportional relationships in the graphs, just like what I just did on the last slide. But we'll start off with some basic graphs first. So to identify proportional relationships, okay, you can tell if two quantities, so two different units, are proportional to each other on a graph if it is a straight line and if it goes through the origin. Okay, so if I look at this graph right here, it's a straight line, okay, and it goes to the origin. Remember, this is the origin, which is 0, 0. Okay, but if given random points, you can ensure it is proportional if each point creates the same value when you divide the y value by the x value. So if I look back at the previous slide, we did the y values over the x values. This is my y-axis and this is my x-axis. So that's what we were doing, dividing the y's, so like 120, over the x, which is 2. So if I look at this graph right here, it's talking about money for my y and number of tickets for my x, all right? And even though it doesn't look like there's a straight line on it, you can pretty much tell that it makes a straight line and it goes to the origin. You can kind of tell, but we don't really know until we test each of those points. So remember, we're going to do y over x. Y over x. So for this one will make 2 over 4, which equals 1/2. Let's see if the other ones also make 1/2. Let's look at this point. That is 3 over 6, because it's y over x. So 3 is my y, 6 is my x. That also equals 1/2. Okay, let's try this one. This is 4 over 8. That also equals 1/2. Let's look at this one. 5 over 10. That also equals 1/2. So that means that this one is a proportional relationship. Okay, so it must be able to start at 0, 0. So if all of those are good, this looks like that one could go through 0, 0 if I were to make a line and extend it. Okay, so it must go through 0, 0 and must create a straight line. Even if we don't give you the straight line, if the points have a repetition of that unit rate, that means it's proportional. Okay, and it makes sense. Okay, if I look right here, it's talking about, for example, if something is 0, 0, okay, it's saying if you don't have money to buy tickets, you don't get any. So of course it starts at 0, 0. Okay, if you go to Burger King and you give Burger King $0, you get 0 burgers. So it kind of makes sense why it has to start at 0, 0. So let's look at graphs without values and see if we can just look at it and tell if it's a proportional relationship without any numbers. All right, so let's look at this one. All right, so I have 6 graphs here, and we need to tell if they are proportional or not. Let's look at A. Is A proportional or not? There are things that, the rules that have to be followed. It must start at 0, 0, and it must be a straight line or create a straight line. So A, okay, it's a straight line, and it looks like it starts at 0, 0. So yeah, this is proportional. Let's look at B. Okay, it's a straight line, but it does not cross the origin, so not proportional. It has to follow both of those 2 rules. Okay. All right, so C, it looks like it could be a straight line and go through the origin, but then it curves up, so it's no longer a straight line, so not proportional. Let's look at D. Ooh, it is not a straight line, it's curvy. It's curvy, and it does not go through the origin, so not proportional. Let's look at E. Okay, it's a straight line, and it goes to the origin. Perfect. Proportional. Let's look at F. It's a straight line, but it does not go through the origin, so not proportional. So what I'm going to do is I'm going to show you the next slide, and it's very similar to this slide. And I want you to pause the video as soon as I get to that slide, and I want you to practice those on your own. Label it as proportional or not, and make sure you have reasons as to why. And then when you're done, press play so that you can see the answers. Okay, we'll go over them. So go ahead and press pause now. All right, let's look at this. So A, hopefully you said not proportional. And the reason is it does not go through the origin. It's a straight line, but it doesn't go through the origin. B, not proportional. Why? It's a straight line, but it doesn't go through the origin either. C, okay, looks like it's a straight line, goes to the origin. Oh, but it is not a straight line. All right, so when you connect the dots, it doesn't make a straight line, so not proportional. D, ooh, it's not a straight line, it's curvy. It does go through the origin, but it's not proportional because it does not follow both rules. It is not a straight line, it's curved. E, straight line, but not at the origin, so not proportional. F, straight line, but not proportional because it doesn't go through the origin, so not proportional. Okay. All right, hopefully you did well with that. All right, so now let's look at graphs with values to determine if they are proportional and then find the unit rate. Very similar to what we did on this slide right here, where we looked at each individual point that was listed and determined if it was proportional. So let's look at this slide. So it says, the graph shows a relationship between the number of miles and the number of hours from a family road trip. Question 1, is this graph proportional? How do you know? Okay, well, let's check to see if it's proportional. All right, so I see a point here, point here, point here. I don't see any main points there, but it's at an intersection. An intersection means that if you're looking at this, it's right in the middle. So try to pick points that are on the exact intersection right there. That's where you want to pick. Okay. So if I'm looking at a graph, I want to pick points here and here because then I know exactly where those values are. For instance, this is exactly 120 over 2, and that was 60. We already determined that. So we will do y over x equals 120 over 2. That's 60. Let's check this one. Okay, that is 180 because it's y over x. 180 over 3 equals 60. Let's try this one. 240 over 4, so y over x equals 240 over 4. That also equals 60. And I keep going, and you can tell the pattern here is my unit rate. That's my constant in proportionality. So 360 over 6 equals 60. All right, so yes, this graph is proportional. How do I know? The unit rate is constantly the same, and it starts at the origin. Look, it starts right here at the origin. Okay, and if you see it's gonna make a line that goes on forever, it's gonna be the same pattern over and over again. Okay, so what is my unit rate? My unit rate, okay, we had y over x. Let's pick a point to show work. Let's do 120 miles over 2 hours. You could pick any point to show your work right here to verify. Yes, you already did show a lot of work here. All right, but that was really to determine if it was proportional or not. Okay. So then I would say, if I divide by 2, because right now this is my rate. Remember, I gotta make it into a unit rate. So then I will say 60 miles per 1 hour. Make sure you always label your units. So I gave you a graph. I asked you, is it proportional? And how do you know? Check each point. If it's the same number over and over again, that means it's the same unit rate over and over again, making it proportional. And it's going through the origin. Question 2, what is the unit rate? Well, you already did all the work when you were trying to figure out if it was proportional, but I do need to see work in this area. Okay, so just pick one of those points and write the work there. And there's our answer right there. 60 miles every hour. Next one. All right, so it says the graph shows a relationship between the total savings in a bank account after the number of weeks working. Okay, it says, is this graph proportional? How do you know? And what is the unit rate? Okay, well, let me put points at the intersections because it definitely looks like it's crossing at intersections. Okay, so I do y over x. And my y, remember this is my y-axis, this is my x-axis. It will never change. Up and down is always y. Side to side is always x. Okay, so I'll write over here. Up and down is the y. Side to side is the x. Okay, so then my y value for this point is 94 over 2. Okay, well, I don't know what half of 94 is, so I'm going to go ahead on the side and do some long division. 2 goes into 9 4 times. That makes 8. 1, 4, 7. 7 times 2 is 14. We get 0. So that's 47. Okay, let's check to see if it's the same thing here. 188 divided by 4, so y over x equals 188 over 4. Okay, I could do my long division for that, and I will find that when I do my long division, I get, what do you know, the same answer. Okay, let's check this one. That's going to be y over x equals 282 over 6. And that will also get me my 47. If I do y over x here and do 376 over 8, I also get 47. So it's the same number over and over again. So yes, this graph is proportional. Okay. The unit rates are all the same. And the line goes through the origin. Okay, what is the unit rate? Okay, well, we already did work, so let's go ahead and use one of them. Pick whichever one you want. Y over x equals $376. You gotta remember, the y is that number. Y represents money over number of weeks. So for this one in particular, it was over 8 weeks. Okay, that's my rate. Now I gotta divide by 8, and when we do that, we get $47 per 1 week. That's our answer. All right, for the next slide, I'm gonna have you go ahead and practice this one. Press pause when I'm done talking, and then you can come back and then check your work. Go ahead, press pause. All right, so let's go over this. The graph shows a relationship between the number of chocolates and the number of bags. So it's all about chocolate, right? Number of chocolates represents my y values because it's up and down. Number of bags represent my x values because it's side to side. Is this graph proportional? How do you know? Well, just looking at it, it's a straight line and it goes to the origin. So yeah, but let's prove it because it says, how do I know? All right, and I want to do some math work. So let's look at these. Good points for me to use would be this one. That's actually the only point that I would want you to use. And the reasoning for that is because it's at an intersection. Okay, if I look at it, if I look at these graphs, it's exactly right there at the cross in the intersection. Okay, all of these, I don't really know what this value is. I don't really know what that value is or this one. And I don't want to approximate these. That's kind of crazy. Okay, I want an exact value. So I'll just go ahead and pick one of these. Okay, and usually the problem will tell you this is a proportional relationship, and you can directly tell it's a straight line and goes to the origin. But right now it says it shows a relationship. Is this proportional? Yes. How do you know? It's a straight line and it goes to the origin. Remember, I taught you how to just identify it, but let's just prove it. Okay, so 40 over 5 So I can do y over x. Well, I want that in complete sentences. So let me see. This is going to be good work for the unit rate. So I'm going to put y over x equals 40 chocolates over 5 bags. Okay, then I'm going to, okay, well, I know that's going to equal 8. But I'm already in the section, so let me just go ahead and continue it. So that's going to be 8 over 1. So there's 8 chocolates per bag. That's my unit rate, but that's going to be the unit rate for the rest of them. Okay, so at this point, you can directly tell me this is a straight line. And it goes through the origin. So it is proportional. And that's enough evidence for me at this point, okay? Because when it looks like this, I don't want you to approximate those, okay? You won't get an exact answer, and we want an exact answer. All right, one more for practice. Okay, this one is talking about a graph that's talking about carnival ride tickets. So go ahead and press pause, try this one, and then come back when you're done. Go ahead and press pause. All right, so this one is saying this is a proportional graph for the cost of carnival tickets. It says, what is the unit rate? It's not asking you what is, it's not asking you if it's proportional. It already told you it's proportional. It said this is a proportional graph for the cost of tickets. What is the unit rate? Okay, well, if it's proportional, each of these dots should represent the same number, so just pick whichever one you want. Okay, so I am going to pick, I like this one because it's at an intersection. I like this one, and I like this one. But the one I'm going to pick is this one right here. And the reason is because I know the exact y value, and I will know the exact x value. For this one, I have to approximate, but luckily that is an easy approximation. All right, but sometimes it may not be so easy. Okay, so this is the one I want. So I'm gonna do y over x equals 60 over 40. All right, and that is $60 over 40 tickets. So I'm gonna divide by, let's see, what can I divide by? Divide by 20. All right, I get 3 over 2. Okay, well, 3 over 2. I don't want an answer like that, so I'm going to have to do some long division here. So let's see, 2 goes into, oh, I'm going to want to write it. Let me see, there's not much room over here, so I'll do it right here. Okay, so 2 goes into 3 one time. 1 times 2 is 2. Subtract, I get 1. Add a decimal, bring it up. There we go. 2 goes into 10 5 times. 5 times 2 is 10. 0. So 1.5. 1.5, my unit rate, if I divide by 2, my unit rate is 1.5 over 1. So $1.5 per one ticket. Huh. Okay, that's what it's saying. So what does this unit rate mean for the graph? Well, I just stated it because I just wrote down my units. I verbally just stated it. But the reason I'm asking is because when you're getting in the groove of writing this, you're getting in the habit of carrying over the units, making sure you're having the money and the tickets, but we want to make sure you're actually processing what it means. So what does this unit rate mean for this graph? It costs $1.50 per ticket. That's what it's talking about. All right, so we talked about what is a proportional relationship. We identify proportional relationships in graphs. Now let's talk about proportional relationships in tables. Okay, that's where we're at right now. So identifying proportional relationships in tables. In tables, Each set of numbers represents a point on a graph. Okay. If the unit rate of each set, so here's a set, here's a set, and here's a set. Okay. If the unit rate of each set equals the same number constantly, then it creates a proportional graph. Yes. Okay. Heads up as a reminder. If one value is 0, the other value must be 0, because remember, it must start at 0, 0. Makes sense because it's the origin. Okay, but it does not need to show 0, 0 on the table. A lot of people think that, oh, I don't see 0, 0, so it must not be proportional. That's not true, because when we show a graph, here's 0, 0, but the points given to us, like 2, 6, and 6, 18, and 8, 24, it may just be talking about this section of the line. Okay, it may not even include this section or this section. Okay, because it's only a section of it. So that's okay. So when we are trying to find if something is proportional in a graph, we're just going to divide the points. Remember, this set represents an exact point on a graph. Right? If I were to graph it, here's 2, because these are my x values. X values are over here, y values are over here. If this is 6, that's my graph, 2, 6. Okay, and what would I do? I would just divide those, y over x. Okay, so what is 6 divided by 2? Oh, that makes 3. Okay, let's check this one. 18 divided by 6. Oh, that makes 3. Good. What about 24 divided by 8? Oh, that makes 3. Oh, it's proportional. This graph is proportional. Perfect. Something I want to mention before we get to the next slide is, what if this were switched and this was x and this was y? Let's see what would happen then. Okay, well, we have to do y over x. Okay, so then my y would be 2 and this would be 6. This will make 1/3 when I simplify. Okay, let's check the other one. It would be 6 over 18. That also makes 1/3. This one would be 8 over 24. That also makes 1/3. See how these numbers are all the same? It's still proportional. Even though it's not 3 like those ones, it's 1/3 because you're flipping the numbers. It's still okay. So when we're finding unit rates, we need to make sure we are reading the units so that we know which number to put on top. Okay, if I give you something like this, pretty much you can choose whichever value you want to be on first. In general, we want you to get in the habit of always doing y over x. But if there are no units involved and we just give you a table like this and we say, is it proportional? You can do it however you want. Okay. Something easy you could have done too was, okay, 6 divided by 3 equals 2. Yep. 18 divided by 3 equals 6. 24 divided by 3 equals 8. That still works. Okay, as long as it's the same number. All right, let's look at this one. Identifying proportional relationships in tables. So which of the following tables represents a proportional relationship? Ooh, we have to check each point, each set. So let's go ahead. Okay, we can do y over x or x over y. It does not matter. All right, so let's just get in the habit of doing y over x. So then this will be, if I do y over x, I got to check each point. It'll be 4 over 1, which is 4. Okay, let's check the next one. So this one represented this one. Let's look at this one. Y over x, 5 over 2. That does not equal 4. All right, oh, what does it equal? Well, let's go ahead on the side. Let's go ahead and divide that out. Okay. That makes 2 1/2. That is definitely not 4, so this is not proportional. Remember, it has to be the same number over and over again. So let me erase that, and I'm going to say not proportional. But it does start at 0, 0, so that's nice. Let's look at B. Oh, I can automatically say that B does not work because if one value is 0, the other one has to be 0. What it's saying is this. At 0, 2, this is where that graph starts, and then it continues, however it does. That needs to be, it needs to start at 0, 0. If we know that proportional relationships must start at 0, 0, but if one is 0, the other one has to be 0, so automatically not proportional. Does not start at 0, oops, at 0, 0. Okay, next one. Okay, both zeros, that's good. Remember, the graph does not have to show the zeros, but if it does, make sure that they're both 0. All right, let's do y over x. That's 3 over 1. Okay, that makes 3. And then the next one, so that made this one. Let's look at this one. 6 over 2, because we're doing y over x, that equals 3. Ooh, we're off on a good start. 9 over 3, that equals 3. Ooh, that is definitely proportional. It's the same number over and over again, same unit rate. Well, let's check the next one. Okay, they're both 0, 0, so that's good. Now let's check this one. 10 over 5, that equals 2. Okay, let's check this one. 15 over 10. Ooh, that does not equal 2, but if I simplify anyways, divide by 5, I get 3 over 2, that equals 1.5. Oh no, just like A, that did not work, so not proportional. A, B, and D, not proportional. So this is a work I need to see. If we ask you which one is proportional, we need to see that you're trying each one. Okay. And even though, say if you do all the work for A, all the work for B, you get to C and you know for sure that's true, that doesn't mean that you should automatically deny D, because you never know. What if that one is true, which really meant C was wrong? So it's a good way to check your work. All right, next one. Identifying proportional relationships in tables. So I'm going to pause right here and I'm going to let you go ahead and try this and come back when you're done. Go ahead and press pause. All right, is this proportional? Why or why not? All right, well, I didn't say what the units were. I didn't say which one was X, which one was Y, so you choose. So I'm going to just do 6 over 2. Let's see, that makes 3. 12 over 4, that makes 3. 16 over 8, that makes 2. Ooh, not proportional. Why? Not all values have the same unit rate. If it is, what is a constant proportionality? It's not. So I'll just write not proportional. Okay, this was kind of a trick question. All right, go ahead and try this one. Press pause after this, try this one, and then come back. Go ahead, press pause. All right, the following chart shows the amount of fish Jason catches for the number of times he casts out. Okay, the number of fish he catches for the number of times he casts out. Okay. Okay, so here's a table. Number of time he casts. Oh no, that's not catches. Casts out is right here. And the number of fish caught is right there. All right. Does there seem to be a proportional relationship? Explain your answer. Okay, so catches to cast out. So catches over casts. Okay. So let's try the first one. 6 over 2. That equals 3. Okay, let's try the next one. 18 over 6. That equals 3. Good. 24 over 8. That equals 3. Okay. 36 over 12 equals 3. Yes. Yes. It is a proportional relationship. It is a proportional relationship. All the values have the same unit rate. Even if you had did 2 over 6 and got 1/3 as your answer, you would still be correct in knowing that it's a proportional relationship, because the question just says, is there a proportional relationship? It didn't say that you had to do it in a certain order. Okay. And just to clarify, if you had done it the other way, say if you did 2/6, the answer would be 1/3. I prefer for you to keep it in fraction form, but if you want to do the long division for it, you'll realize that is 0.333 repeating, right? As long as it's 0.33 repeating for each one, that works. So you can do the fraction and stop there, or if you wanted to do the full long division, you could if you wanted to, and your answer will still have the same value. It will still be the same. All right, so we talked about what is a proportional relationship. We saw them in graphs, in tables.